There is a concept called adjacency matrices. And the way it works is when you have some points, in this case I have these points, this is actually a somewhat of an abstract picture of the United States. And let's say this represents cities, Miami, New York, Chicago, Denver, Los Angeles. And there are flights that go from one city to the other. Sometimes the flights go in both directions. So let's say there is a flight that goes from New York to Chicago. I'll put an arrow from one to the other. And let's say there's not only a flight from Miami to New York, there's also a flight from New York to Miami. So I'll put an arrow on both ends of that. And let's say from Los Angeles to Chicago, there's arrows. You could fly either of those places. I could fly from Denver to Miami, but for whatever reason, I can't fly back from Miami to Denver. And finally, I'll put some arrows here, Denver to New York, and on the other side there's an arrow from New York to Denver, Denver to New York. So I can use a matrix to represent what's going on here. And in this case, that matrix would be a 5 by 5 matrix. And here I've labeled the rows and columns NDMLC and NDMLC. I want to make the columns represent the sort of starting city where the trip starts from, and the column, the rows that is, are going to be where it ends up. And the way these adjacency matrices go, at least at this point, is I'm going to put a 0 if there's no trip that goes from one city to the other. For instance, there is a trip from Denver to New York, as I can see Denver to New York, so I'll put a 1 there if there is a way to get from that place to the other place. There is from Miami to New York, but at least in this picture, there's no Los Angeles directly to New York. So I'll put a 0 here. There's nothing straight from Chicago to New York. There is from New York to Chicago. We'll see how that works. And you can't really fly, at least, you can't fly from New York to New York, at least the way that this goes. There is no trip that does that. And if I fill that in for the rest of the numbers, I get something that looks like this. And this represents zeros, meaning there is no trip that starts in the city that's labeled by the column and ends in the city that's labeled by the row. So I could just look at this matrix here and say, is there a flight from Chicago to Miami? And because there's a 0 over here, the answer would be no. On the other hand, if I say, is there a flight from Los Angeles to Miami? I would say yes, although for some reason I don't think I drew it in. Yes, I forgot to. So let's draw that in. It's actually in both directions. Los Angeles to Miami, Miami to Los Angeles. So as you can see, this picture of the map is pretty hard to follow what's going on. It's pretty confusing, whereas this matrix expresses the same information, but in a simpler way. And it doesn't have to have cities. I could just make a general thing, A, B, C. So like test type question I could ask. I could just draw some arrows. You can even make something go to itself like that. A, B, C, D. And I could ask you to draw an adjacency graph, adjacency matrix. And in this case, it would be 1, 1, 0, 0, 0, 0, 1, 1, 0, 0, 0, 1, 1, 1, 0, 0. So being able to go from the picture, which is called a graph, it's got these points are actually called nodes, and the lines are actually called edges. We say that two things are adjacent if there's an edge connecting them. And here's my map again. And I might ask a different question, which is, what if I want to have what's called a layover? Maybe it's cheaper. A layover is where you have to, I want to go from New York to Chicago, but instead of going direct, maybe it's cheaper to go to New York, from New York to some place, and then from that place to Chicago. Let's just say that that's cheaper, even if it takes a lot longer. Well, now if I made a list of all the ways of getting from Miami to Los Angeles with one layover. So even if there is a way to go straight, which there is, but we're not allowed to go that way. We must use one layover. So we look at our picture and we say, okay, well, there is a way to get from Miami to Chicago, and there's also a way to get from Chicago to Los Angeles. So I'll write Miami to Chicago to Los Angeles. I think that's the only way. If I want to have exactly two layovers, so that's from Miami to somewhere, and then to Los Angeles. Let's say that's like really cheap. Can that be done? Well, one way is from Miami to New York and then to Chicago. So I can do it with two layovers. There are other ways. For instance, I could go from Miami to New York, back to Miami, and then to Los Angeles. That might seem like a pretty pointless thing to do, but if it saves you a lot of money and you can't afford it, maybe that is a good thing to do. Well, there is a way to use matrices to figure out the answer to these questions with one layover and two layovers. And it goes like this. If I take the original adjacency matrix and I were to, either using a calculator or by hand, square it, multiply it by itself, I would end up with another 5 by 5. And the answers to this, ND-MLC, ND-MLC, this would be the ways with one layover. And not only that, it would have how many ways. If they see there's twos in there also. So if I come back to the last question, from Miami to Los Angeles, according to this, Miami, Los Angeles, this claims that there's two ways. Oh, actually, now that I look at it, this is the number one. And that's the number of ways of going from Miami to Los Angeles with just one layover. I want you to notice that there's some numbers on the diagonal here. Unlike here where these were all zeros, these have numbers because you could go from New York back to New York two different ways with one layover, or from Denver to Denver back and forth to a different city with one layover, so you can get back. So these numbers now represent how many ways there is to do that. And one thing you're going to think about in class is, why does this work? And if you raise this to more powers, you can get a number of ways with 2 layovers, 3 layovers, as many layovers as you want. The last thing I want to mention is if you add together the original matrix, which tells us how many ways there are to get from one to the other, one place to the other directly, and the second matrix, the square of the first, tells us how many ways I can get from one to the other with one layover. If I add them together, I get this matrix. And those numbers represent the number of ways I can get from one city to the other with, at most, one layover. So usually you'd be happy to have less layovers, so if you add these together, like this number 3 means I can get from Miami to Los Angeles 3 ways if I'm allowed to have one layover or no layovers.